In this video, we're going to go over the difference between a combination and a permutation. Also, we'll go over two different formulas, one for calculating the number of possible combinations and one for calculating the number of possible permutations. So imagine that there's these three shapes, a square, a triangle, and a circle. The three shapes can be whatever you want. For example, they could be three different blocks. And imagine that you're selecting two of the three shapes. If you're selecting two of the three shapes, then these are the possible combinations that you could select. You could select the square and the triangle. That's one possible combination. You could select the square and the circle. That's another possible combination. Or you could select the triangle and the circle. That's the third possible combination. So basically there's three ways to select two shapes from these three shapes, and those are the three possible combinations in this situation. So anytime you're selecting two items from three items, there's three possible combinations. So let's say you open up your refrigerator and you see three different food items inside there. Like let's say you open up your refrigerator and you see a piece of pizza, a hamburger, and an apple, and you select two of the three. You decide that you want to select two of the three food items to eat. Well, since you're selecting two out of three items, there's three possible combinations. Or let's imagine that you have three different bills that you have to pay, like let's say rent, energy, and your phone, and you only have enough money to pay two of the three bills. You don't have enough money to pay for all of them. So you decide to select two bills and pay for those only. Well, since you're selecting two things from three things, once again you have three possible combinations. You have three possible choices. So there's in this situation, there's actually a formula that would tell us that there's three possible combinations. In this picture, I decided to just write them out visually to show you that there's three combinations, but we could have done this just by using a formula. But I wanted to do it with a picture first to make sure you understand why there's three combinations. So this is the formula that's used to find the number of possible combinations. So you have n, which is the total number of items. It's the number of items in the pool of items that you're selecting from. So in the picture that I just showed you, there was n would have been 3 because you're selecting from three different shapes. X is the number of items that are being selected. So in the situation we just looked at, X would be 2 because we're selecting two shapes from three shapes. So yeah, n was 3, X was 2. This exclamation point is factorial, which this is something you might have seen before in a different class, but I'll explain what it is quickly. So the factorial sign means you multiply all numbers from that number down to 1. So if you see a 3 with this exclamation point, that would be 3 times 2 times 1. If you see 2 with this exclamation point, it's 2 times 1. And if you see if you just see 1 exclamation point, that's simply 1. So it's you start at the number and multiply going down all the way to 1. So let's do one example right here of finding the number of possible combinations. So this one says, how many 2-item meals can be created from a menu of 5 items? So we're selecting 2 things from 5 things. So n is 2 and n is 5 and x is 2. And we have our exclamation point. So first we need to subtract right here in the parentheses. So 5 minus 2 is 3. We have 3 right there. Now we just have to expand all of this out. So on the top we have 5 times 4 times 3 times 2 times 1. On the bottom, the 2 with the exclamation point will be 2 times 1, and the 3 with the exclamation point is 3 times 2 times 1. We can cancel out these numbers because they're the same on the top and the bottom, and that leaves us with this. But if you cancel out some of these numbers, you have to remember that you can only cancel them once. So notice at the top how we crossed off the 2 times 1. So that's once that's canceled out, we can't cancel it out with this other 2 times 1 right here. So you can't cross off the 2 times 1 on the top and then cross off both of these 2 times 1s on the bottom. It's kind of like once you spend $1, it's already gone, and you can't spend it again. So we have 4 times 5 times 4 and 2 times 1. And also, before we move on, I want to say it's good to cancel as many numbers as possible. That's why I canceled 3, 2, and 1. So yeah, 5 times 4 is 20. 2 times 1 is 2. Then 20 divided by 2 is 10. That's the answer. You just divide the fraction. So now let's talk about the definition of a permutation. So a permutation is a certain type of combination. It's an ordered combination. So if we're selecting 2 shapes from these 3 shapes, that's these are the possible permutations. You could have the square first, and then the triangle. You could have the triangle first and then the square. You could have the square first and then the circle, or the other way around. And you could have the triangle and then the circle, or the other way around. So to get the possible permutations, you just list out the 3 combinations like we did earlier, and then you just write out the reverse of each combination. And that gives you the 6 permutations. So each permutation is basically a possible sequence of 2 items. So I think, let's see. So let's go back to that that example in which you're paying 2 bills. Well, you have 3 bills that you're supposed to pay, and you can only pay 2 of them. So let's say that the 3 bills that you have to pay are rent, power, and your phone. And you decide to pay for rent and your phone because that's all you can afford. Well, that's a combination, right? The rent and your phone is the combination that you've chosen. But if you decide to pay for rent first and then your phone second, that's a permutation. That's a sequence. And if you decided to flip the order around and pay for your phone first and rent second, you're paying for the same 2 things, but in the opposite order. So it's now a different permutation. It's the same combination, it's the same 2 things, but a different order, so it's a different permutation. So yeah, so there's, I think a good real-life example of a permutation is maybe a zip code, because when you, well, a zip code is 5 digits, and the order matters, because if you take 2 of the digits and you flip them around, it becomes a new zip code. So let's see, 94521 is a zip code. But if you flip the last 2 digits around, it becomes 94512, which is a new zip code. So since order matters, you would each zip code is a permutation. A student ID number or a locker combination would also be permutations. So when you so basically a combination is when order doesn't matter, and a permutation is when order matters. So here's a formula that can be used to find the number of possible permutations. So you have n and x. Well, it's actually almost the same exact formula for the number of combinations, except one thing is left off. So notice here in the formula for combinations, you have an x on the bottom at the left end. You take that off. If you take that x off, you get the formula for permutations. So basically just this x that used to be here is missing. And these things have the same meaning as they did before. So let's go over an example of finding the number of possible permutations. So this one says, how many different arrangements of 3 flowers could be created if 5 flowers are available? So in this situation, you're taking 3 flowers out of 5 choices, and you're going to put those 3 flowers in a certain order to make a sequence. So notice how this, since this question is asking for the number of possible arrangements, it's asking for the number of possible sequences. So that means the permutation formula has to be needed. Because if you pick 3 flowers and if you flip the order of 2 of them, it becomes a new arrangement. Like I said, order matters in this situation. So we have 3 flowers from 5 flowers. So on the bottom, 5 minus 3 is 2. Then we just cancel off these 2 numbers, and we have 5 times 4 times 3 is all that's left, and that's 60. And notice how it's a big number because if you think about it, there's a lot of possible sequences that could be created, right? So it makes sense that it would be a big number. Now, let's imagine that I asked you how many different, imagine I ask you how many different 3-digit ID numbers could be created from 9 digits. So in that, if I asked you that, it would be this same formula. So if I asked you to imagine that you're choosing 3 different digits out of 9 choices, and you're taking those 3 digits and making an ID number, and I asked you how many ID numbers could be created, you would do this because you're looking for the number of possible arrangements, right? So yeah, that's it for this video.